Okay, so let's start with the correlation matrix now. So let's first clear all that kernel, clear all the outputs. Yes, we'll clear everything whatever is there, and then we will start the correlation matrix. Now we'll be constructing a correlation matrix. Each row and column represents a variable, and each value in this matrix is the correlation coefficient between the variable represented by the corresponding row and column. The correlation matrix is an important data analysis metric that is computed to summarize the data to understand the relationship between various variables and make decisions accordingly. It is also an important pre-processing step in machine learning pipeline to compute and analyze the correlation matrix where dimensionality reduction is desired in a high dimensional data. We mentioned how each cell in the correlation matrix is a correlation coefficient between the two variables corresponding to the row and column of the cell. So let us understand what a correlation coefficient is before we move to the actual exercise. So what exactly is the correlation coefficient? Although we have done it in our tutorial, a correlation coefficient is a number that denotes the strength of the relationship between the two variables. There are several types of correlation coefficient, but the most common of them all is that Pearson's coefficient, denoted by the Greek letter rho. It is defined as the covariance between the two variables divided by the product of the standard deviation, where the covariance between x and y, covariance kx of xy, is further defined in the expected value of the product of the deviation of x and y from their respective means. So plotting the correlation matrix, for this explanation we will use a data set that has more than just two features. So we will be using a breast cancer data, a popular binary classification data. We'll load this data set from this scikit-learn's dataset module. It is returned in the form of the numpy array. So but we'll convert them into the pandas data frame. So let's start from sklearn. We are going to load now, import all the libraries, that is sklearn datasets, import load breast cancer, import pandas, breast cancer is going, all these things is simple. Breast cancer is equal to load breast cancer, so it is loaded. Data is equal to breast cancer data, it is loaded in the data now. Features is equal to these are the features which are there, and df is equal to pd data frames data columns is equal to features. So when we print this, we can get the shape and the features, right? So I think we can just run it. So let's start and running right from the beginning itself. Let's run this first, then we can run this also, then we can run this also. Of course these are all remarks, so nothing is going to happen, but certainly we need to run them. So now we are going to run this particular cell. So when we run this cell, we are going to see that yes, after due processing, because the libraries are fairly big, so all these libraries will get imported first, and then of course we will have our data shape and the features. So let's wait for some time. Yes, it is done now. So we can see that we have got these, the shape is 569 rows and 30 columns, and the features are mean radius, mean texture, mean perimeter, mean area, all these features which are there, and which are 30 in number. So that is what all of them are presented here, right? Now moving further on, import cboard, then import matplotlib, then df small. We are taking only 6 columns. That is what is mentioned, taking all rows, because this shows the rows and this is the column. So we are taking only 6, starting from 0 to 6. So 6 columns, that is all these 6 columns are being taken and all the rows. Then correlation, of course we can do that. Correlation mat is equal to df small correlation, then SNS heat map we are going to generate with the help of this. So SNS heat map, correlation matrix, annotation is true. That means we will get the number also within the blocks. So we can run it and we will see that how we are going to get it. So this is the kind of a correlation matrix that we get, and you can see that each block has a number. Now this number is the correlation coefficient between the two variables, and the variables you can always say x and y, like this and this, this and this, like that. So you can always have a combination of x and y, and you can see that what is the coefficient number in that, right? Now the plot shows a 6 by 6 matrix that we can see, and color fills each cell based on the correlation coefficient of the pair representing it. So Panda's data frame correlation method is used to compute the matrix. By default it computes the Pearson's correlation coefficient, that is by default. If you specifically mention Spearman's, of course then the Spearman's method will be used. We could also use other methods such as Spearman's coefficient or Kendall or tau correlation coefficient by passing an appropriate value to the parameter. So that we have to specify. We have used Seaborn's heat map that we have seen to plot the matrix. The parameter annotation is equal to true displays the values that is there, that is correlation coefficient in each cell. Now let us go further. One must keep the following points in mind with regard to the correlation matrices, such as all those points that we have seen, that is each cell in the grid represent the value of the correlation coefficient, the value of position A and B represent the correlation coefficient between the features, and the column B, this will be equal to the value of the position BA. It is a symmetric matrix. All diagonal elements are 1, since diagonal elements represent the correlation of each variable with itself. The axis ticks denote the feature each of them represents. A large positive value near 1 indicates a strong positive correlation value of the variables. A large negative value near -1 indicates a strong negative correlation. That of course we have done in the correlation when we did that in tutorial. Then a value near to 0, both positive or negative, indicates the absence of any relation. That means there is no relation. And then each cell in the above matrix is also represented by the shades of the color. So that is how we can make this. This scale is given with the help of the color bar. So color bar is also given, that is mentioned like here. These are the different color bars, so that you can easily relate it. Now moving further on, we can say that this adding title to the same matrix that we have made, we can add titles. So we can tweak the generated correlation matrix just like any other matplotlib plot. So and let us see that how we can add a title to that. So correlation matrix, DF is small correlation that we have selected, SNS heat map, and we are adding the title to that. That is PLT title correlation matrix of breast cancer data, and then X label cell nucleus features, and Y label cell nucleus features. So both sides you are having nucleus features, and when we click on the plot show, you will see that this is going to. So let us first click all those which we have not done, like here. Now this one was done. Here this also we have to run. So we have run that. We are going to run this also. This can also be run now, executed. Then moving on further, we can run this also. Then we are going to run this one. So once we run this, you will see that now we have got the title, correlation matrix of breast cancer data, and here we have got the cell nucleus features, and here also we have got the cell nucleus feature, and all those specific names are also presented here, those features, right? Now the next is that if the given data has a large number of features, the correlation matrix can become very big. Hence it is difficult to interpret. So therefore we might want to sort the values. So we can sort it to the matrix so that the strength of the correlation between various features pairs in an increasing or decreasing order. So we can get the strength, that how strongly they are related. That's important. So first we will convert the given matrix into a one-dimensional arrays. So we can convert that with the help of this. That is correlation matrix is equal to D of small correlation, then correlation pair correlation matrix unstack. Now this will do the unstacking and print correlation pairs. So once we do that, you can see that they have been unpacked. Mean radius, mean texture, perimeter, area, smoothness, all of them have been unpacked now. Now this unstack method is the pandas data frame returns a series with the multi index, that is each value in the series is represented by more than one indices, which is this in this case are the row and column indices that happens to be a feature name. Let us now sort these values using the sort values method of the pandas series. So that's how we can go for the sorting of this. Sorted pair is equal to correlation pairs, sort values, kind, quick sort. This is the method that we are going to use, and then we are going to print this also. So this is how, when we run this, you are going to get this kind of a data output, right? Now we are going to, you can see each value is repeated twice in the sorted output. Why? Because this is because our correlation matrix was a symmetric matrix and each pair of features occurred twice in it. So that is the reason why we have got all this appearance twice. Now we have sorted the correlation coefficient, the values of all pairs of features, and can make decisions accordingly. So just by looking at this, I mean, we can make our decisions. But let's go a bit further. Now we are going to select the negative correlation pairs. That is, we may like to select feature pairs having a particular range of values of the correlation coefficient. Let's see how we can choose pairs with a negative correlation from the sorted pairs we generated in the previous section, right? So we can do that also. And now this negative pairs is equal to sorted pairs, that is sorted pair is less than 0. That is why it is my negative. Print negative pairs. So we can print this and we can see that only two, that is mean smoothness minus 0.023389 and mean texture, it is again same value. And this is how we got this. Now next we are going to select strong correlation pairs. Now, like we have seen the negative, we would also be interested in the strong relationship. So let's use the same approach to choose strongly related features. That is, we will try to filter out these features pairs whose correlation coefficient values are greater than 0.5 or less than minus 0.5, right? So this again we can run. Then strong pairs, sorted pairs, absolute sorted pairs is greater than point. That is what our objective. We want to find out that how strongly they are related, and they should be more than 0.5. So print a strong relationship, we can do that and see that all of them are going to be more than 0.5, right? Now converting a covariance matrix into correlation matrix. Now we can do convert that also. So we have seen the relationship between the covariance and correlation between a pair of variables in the introductory sections. So P, it is not P, it is rho actually. A rho means that is the relation XY, covariance XY divided by sigma, that is standard deviation, and sigma Y, sigma X, sigma Y, that is standard deviation X and standard deviation Y. Equation of relationship between the correlation and covariance. So let's understand how we can compute the covariance matrix of a given data in a Python and then convert it into correlation matrix. We'll compare it with the correlation matrix we had generated using a direct method call. So we can run that. Now, first of all, Panda doesn't provide a method to compute covariance between all pairs of variables. So we will use NumPy. Now we can't use Panda, so we have to convert it into NumPy and then we can use it. So we can do that. So we can first we need to import NumPy because that is the requirement, and then we can run this. So once we do that, you can see that all these covariances are generated, and we can have it as as it is appearing here. Now we are passing the transpose of the matrix because the method expects a matrix in which each of the features is represented by a row rather than a column. So we have gotten our numerator right. Now we need to compute a 6 by 6 matrix in which the value of ij is product of a standard deviation for features at positions I and j. We will then divide the covariance matrix by this standard deviation matrix to compute the correlation matrix. So let us first construct the standard deviation matrix. So we can run this also, right? So compute standard deviation for each of these 6 features. Standard deviation, that is STDS, NP, standard deviation, df is small, axis is equal to 0, and shape is like this. Is of course remark, so nothing to worry, but yes, this is only for our information. Standard deviations matrix, NP array is STD I, STD is j, because ij both we want, and for j on range 6, for I in range 6. So because both are going to be considered for this. So print standard deviation matrix of shape, STDS standard matrix shape. So once we run it, you will see that you are going to get a standard deviation matrix of shape 6 by 6, right? Now that we have the covariance matrix of shape 6 by 6 for the 6 features and a pairwise product of features matrix of shape 6 by 6, we can divide the two and see if we get the desired resultant correlation matrix. So that also we want to check. So that we can get it with the help of this new correlation is equal to covariance standard deviation matrix. So we can run it, and we can, this of course it has created a new correlation. Then we have stored this is what we have done. We have stored the new correlation matrix derived from a covariance matrix in the variable new cor. This. Let us check if we got it right by plotting the correlation matrix and juxtaposing it with the earlier one generated directly using the pandas method. So see here, now this has been run. So now we are going to again create a heat map. So plot figure 18,4, subplot 1 to 1, heat map again is to be generated, earlier correlation matrix from pandas, cell nucleus features that we have seen again on the X label and Y label, subplot 1 to 2, SNS heat map correlation matrix, annotation is true, new correlation matrix from covariance matrix. Now this is a new covariance matrix. So we are going to have both side by side, both the matrices, right? And X label cell nucleus almost similar, you will see. So once we go and execute it, you will see that a similar type of, exactly the same, in fact, no difference. The only thing that it is earlier matrix with pandas and this is newer correlation matrix with covariance. That is the only heading part is only different, otherwise you will not find any difference, right? This means that our logic is correct, our algorithm is correct, and we can compare the two matrices and notice that they are identical. So we can run this also. Now exporting the correlation matrix to an image. Now we can also check by exporting it to an image, and this image will get stored in your working directory. So plotting the corresponding correlation matrix in a Python script is not enough, so we might want to save it for the later use. So we can save the generated plot as an image file on disk using the plot save figure. So we can run this. Now correlation matrix, by same correlation that we have created, and then SNS heat map correlation matrix, annotation is again true, plot title is correlation matrix of breast cancer data, cell nucleus features again breast cancer correlation PNG. So this here we are creating a PNG file. This file will get created because of this code that we have written here. So we can run it. So once we run it, you will see that it will create that. It will print here, and it will also create a PNG file there in the working directory. Whatever directory that you are having, you can check it with the pwd. So you will get the name of the directory. You can go there and see the breast cancer correlation.png, the same name, breast cancer correlation.png. This file must be there. Now So you can see that after you run this code, you can see an image file with the name breast cancer correlation.png in the same working directory gets created. Then the conclusion is that we learned that what a correlation matrix is and how to generate them in the Python. We began by focusing on the concept of the correlation matrix and the correlation coefficient. Then we generated the correlation matrix as a NumPy array and then as a pandas data frame. Next we learned how to plot the correlation matrix and manipulate the plots label, title, etc., etc. So we also saw how we could perform certain operations on the correlation matrix, such as sorting the matrix, finding negatively correlated pairs, finding strongly correlated pairs, etc. So then we discussed how we could use a covariance matrix of the data and generate the correlation matrix from it by dividing it with the product of a standard deviation and of course individual feature. So finally we saw that we would save the generated plot as a image, and that of course we can run here and we can see the file has also got created in the working directory. So if you want to see, we can go to the working directory. This is of course not that. Okay, let us try and see that also. Go to C, go to users, then go to debug, and then we can have the breast cancer. See here, breast cancer correlation, which is created just now. So if we click on this, you will see that this image file gets created and we can see this also. Right, yeah. So the same image that we saw there, now we are having it in the image form, PNG file, and that is also created and stored in your working directory. So this confirms that our working is correct. So we stop it here, and then we are going to stop it. So thank